Good morning, Algebra 1 students. We're going to start our next unit. It's a very small unit, just going to be 2 lessons, and we're going to be talking about square root functions a little bit, only because we should have some of this stuff kind of fresh in our mind from our graphing of quadratic equations. We're going to use a lot of the same things that we did in those equations to graph square root functions. So last chapter, we started off with a base graph that looked like, and we did the graphs like f of x is equal to x squared, all right? Those were quadratics, those made a parabola, okay? Well, now we're going to do the inverse of that. We're going to do f of x is equal to the square root of x, right? So a little bit different, and it makes a little different graph, okay? It kind of looks like a parabola, but it's going to be sideways. It's going to still go through, let me get a different color here for you. We're still going to go through 0, 0 as its base graph, and it's going to go through 1, 1, okay? But then it's going to kind of curve this direction, okay? There's not another half of it, okay? Normally we might expect to have that other half down here, but that is not going to happen, okay? That is not going to be there. So it's just 1/2 of a sideways parabola. Okay, so we're going to have the square root of x. And then just like we did with our parabolas, we're going to have all the same types of things that we can do with it. So for example, let's do this. All right, let's multiply that by a 3 there. So what does that do? That gives us a vertical stretch by a factor of 3. So now instead of it going through 1, 1, it's going to go up here through 1, 3. And instead of going up here at 2, 4, where it was supposed to go through, 4, 2, excuse me, it's going to go through 4, 6, right? So we're going to stretch it up in this direction here, okay? And you can just see it pulls it vertically up. Whereas if I graph something that had a 1/2 in front, right? That's a vertical shrink by a half, right? So we take this original blue line and it's going to take us down to 1/2 of everything, right? So it's going to get kind of just lower vertical shrink. Okay, sorry, that should go through 0, 0 still. So vertical stretches, vertical shrinks, all those things still happen. Okay, so let me kind of start over a little bit and let's just kind of add something here real quick. So f of x is equal to 2 square root of x plus 2. Okay, so what do we have here? Well, that 2 right there gives us a vertical stretch. Okay, and what does, sorry, all right, and what does that 2 do? Well, let me draw that over here. Okay, that's a vertical shift up 2. Okay, so those are the 2 things that those 2 numbers do. Remember, if that was a minus, it'd be a vertical shift down 2, right? So instead of our normal graph, which I'm going to do with a dotted black line, sorry, let me try that again. Okay, because I know it's got to go, our normal graph's got to go through 1, 1, and it's got to go 4, 2, and it's got to go 9, 3, because those are perfect squares. Okay, and so it's going to follow that path. Okay. All right. Now, if we do a vertical stretch by a factor of 2 and shift it up 2, so instead of going through 1, 1, and actually let's start at 0, 0. Instead of going through 0, 0, we're going to move it up 2. All right, and we're going to go right there. And then instead of going just up through 1, 1, we're going to double that. And so it's going to go up through there. And so we're going to stretch it, we're going to stretch it by a factor of 2. Okay, so we shifted it up 2 and we've stretched it by a factor of 2. Okay, let's do a different graph. Let's do f of x is equal to negative. Let's get a little tricky here. How about square root of x minus 3 minus 1? Okay, so this time I hope that you can see that we have a negative sign here, and we should know what that negative sign does. It's going to flip it, right? It's a reflection in the x-axis, okay? And then this part that's underneath the square root, that is going to move it. Remember, it kind of works opposite because we've got to think about what makes that 0. That's going to move it to the right 3, okay? And then this guy is going to move it. It's going to be a vertical shift down 1, okay? So we have a flip. We're going to shift it to the right 3. We're going to move it down 1. Now, normally we start at 0, 0, but we're going to shift it to the right and down 1. And so we're going to start right at that point right there at 3, negative 1. You can kind of think of that as the vertex, even though technically there isn't one for a square root function. Okay, so we're going to now go upside down though. We're going to flip it. Normally it would go up here, okay, but now this time it's going to go down through here. Okay. Now, I'm not really that concerned about the exact shape of your square root function. If you can show me that it's a vertical stretch, but it's not exactly by 2 or 3 or whatever the number is, that's fine. I definitely want to see your translations vertical shift. Vertical shift down 1 and your horizontal shift to the right 3. I definitely want to see that point right there. Okay, but then just draw the graph. And of course, you got to show that it's flipped as well. Okay. Actually, let's talk about the domain and range real quick while we have this. Okay. So is the domain all real numbers now? Well, no, it's not anymore because we're talking about a square root function. And remember, with square root functions, you cannot take the square root of a negative number. So that's going to change things a little bit. Okay. Because of that, the fact that we moved it to the right 3 means that our domain now, instead of saying all real numbers, we're going to say x is greater than or equal to 3, right? Because we shifted it to the right 3. Normally we would say x is greater than or equal to 0, right? Because that is a positive number. We can't take the square root of a negative number. And then the range, because this one started at negative 1 and went down, we'd say y is less than or equal to negative 1. Okay, so there's a lot there. I'm going to just give you a couple of problems on this, nothing too major. Okay, but before I do that, I want to kind of go through all the different things that could happen, right? So let's start with this. Okay, let's do the square root of x minus h, right? So that is a horizontal shift h units, right? It could be right, it could be left, but if it's inside the square root, then it's a horizontal shift, just like we did with our parabolas, right? Sorry, that's supposed to be a plus. There we go. Now, if there's a number outside of the square root, like this plus k here, then that's a vertical. That's a vertical shift. K units, right? Up to down 4, whatever it happens to be. Okay, so that's the first thing. Then we could have something like negative square root of x, right? Okay, so that flips it over the x-axis, right? Flips it that way. But if we didn't have this with parabolas because they had symmetry, but if we put the negative on the inside, okay, then that flips it horizontally. So anything that's done inside the square root is gonna mess with it horizontally. So that's gonna flip it over the y-axis, right? So that's gonna go in that direction. Okay, so negative signs flip, but one flips it up and down, the other one flips it left and right. If we get a horizontal flip over the y-axis, it's going to make it go this way. Okay, so let's do the next thing. All right, if we have a number out in front there, okay, well, let's see this. If a is greater than 1, then we get a vertical stretch. Okay, and if a is a fraction, if it's less than 1, then we get a vertical shrink. Okay, so those are all the different things that that you could see. Okay, I'm gonna just try to give you one of each type of those equations on your homework. So feel free to go back and look at this whenever you need to. Okay, and I think that's about it for our graphing of square root functions. All right, thanks guys.